is to measure air quality dynamically on the road using cycles. So as you can guess, a sensor for air quality is a vital part of the sensor of the final device section. So first off, air quality can be bad for many different reasons, but on roads, the reason why air quality is bad is traffic, so cars. As you can see, cars can emit a very nice variety of pollutants. So nitrogen oxides, carbon oxides, volatile organic compounds, and particulate matter. So potentially you can measure all of them using existing sensors, but given the time and money constraints that we had, we decided to focus on one, which in our case was particulate matter. So particulate matter is a very fancy name for meaning fine dust that we breathe. It's suspended in the air all the time. It's so small you cannot even see it, but it's there. The biggest particles are about 1/3 of the diameter of a hair, and they're small enough for our body to take them up easily, but they're not big enough for our body to expel them easily. So they're in a very critical range, and they're very bad for us. So there is the reason number one why we decided to go for particulate matter sensing. Reason number two is that some pollutants in Cambridge, like nitrogen oxide, their levels are so low that you cannot really detect them unless you have very top-notch sensors. And we want to keep everything very low cost because we want people, like all the cities, to be able to build and get our sensor. So we didn't build the PM sensor ourselves, we just got one. So we got this SDS-011 one, which measures PM 2.5 and PM 10. So in terms of micrograms per cubic meter. So it's fairly easy. Air goes in through the inlet, then there is a fan that the fan sucks the air in, and then there is a laser and the photodiode, and by dynamic light scattering we get the amount of PM 2.5 and PM 10. So it works in the -10, 60-degree range, which is fine for us. And we put it in a clean room where we knew that PM 10 and PM 2.5 values were 0, and we got 0 out of it. So there was no baseline correction to be made, but obviously we wanted to know if the sensor was giving values that were real or not really. So we wanted to calibrate the sensor. So for doing it, we put the sensor on top of an official monitoring station here in Cambridge. I don't know if you can see it, it's up there, here. And we left it there for a few hours. And this is what we got out with. So our sensor, this one, underestimates the values. But it's good enough for understanding when PM10 is going up or when it's going down. So we decided to not really go for sensing particulate matter in absolute terms. So we don't really care to know if on a particular road at a particular time PM10 level is 2.5 or 17.65 or whatever. We just want to know what roads are nicer to cycle on and which roads are not so nice to cycle on. So from now on, everything we show is relative to Cambridge. So low levels are low for Cambridge and high levels are high for Cambridge. So what we did next, this is a bit of a spoiler of what's coming next. So all of us got a sensor and we went cycling through Cambridge, like all of us at the same time, to build dynamic air pollution maps of the city